All right, so today what we're going to do is we're going to take a look at a real quick run through the units that we've done, and I'm just going to do a kind of flash review on each one, and then I'll take you through some examples from each of the cumulative reviews. So thought the cartoon was a little bit fitting. I love math, but I like math puns too. So math puns are the first sign of madness. All right, so let's jump into the first unit. So the first unit that we did this semester was polynomial and sinusoidal functions. So the first thing that we did, if you remember, we did that activity where we were all working together and trying to figure out which types of functions were quadratic or cubic or sinusoidal. We looked at constant functions and linear functions, and we talked about their degrees. And so if we take a look at the different types of functions that we have a constant function, which has a degree of 0, so it's going to be horizontal. We have linear functions. Linear functions are diagonal lines, and they have a degree of 1. And then we have quadratic functions. Quadratic functions I call our smiles and frowns, so they open up or they open down. These will have a degree of 2. And so when we're talking about degree, we're talking about the value of the exponent for the variable. So this would be y equals a constant, so there is no variable. Degree of 1 would be something like y equals mx plus b. Degree of 2, y equals ax squared plus bx plus c. We also looked at cubic functions, which could look like this, could look like this. They could also have a point of inflection. Okay, in other words, there's no max or min, a point of inflection. So that's where the graph kind of levels off but doesn't actually change direction. So these would all be examples of functions that have a degree of 3. And so then we also talked about odd functions versus even functions. So if I have an odd function, the end behavior, both tails are going to end in the same direction. So if I have an even function, both tails are either both pointing up or both pointing down. If I have an odd function, then one tail might be up and one tail would be down. All right, we also looked at the leading coefficient. So if I have a leading coefficient for a degree of 1 and the leading coefficient is positive, then the graph is going to be rising up to the right. If it's negative, it's going to be falling to the right. Quadratic functions, the positive would be smiling and the negative would be frowning. And then with cubic functions, same thing. If it's positive, just like with the linears, it'll be rising to the right, rising to the right. If it's negative, it'll be falling to the left. And so then when we got into sinusoidal functions, we did a lot of applications with regards to word problems. So you had a table of values, we had to do a regression. So if you remember on our calculator, we had to cut and paste functions in. So you might want to go back and take a look at your calculator cheat sheet on how to do that. We had to look for different things. I'm just going to add a new screen here. We had to look for some different things like zeros. So where the function crossed the x-axis. So I might have had a quadratic function that opened up or one that opened down. Let's say the one that opened down, it crossed these 2 points. Those would be called our zeros. So on our calculator, we could actually look for the zeros, or we could draw a line at y equals 0 and find the intercepts. Okay, we would have a maximum value here, so we could find that with our calculator. Or if the graph was opening up, we would have a minimum. We also had to do domain and range. So for a quadratic function, for example, we would have had x is the element of reals. And this is just for a standard function. If it's in context, that might have to change. And then we might have y is greater than or equal to the minimum, or we might have y is less than or equal to the maximum. Window settings often became an issue when we were in this unit because we had to look at the context of the question and then decide how to adjust our window settings. Now, once we finished with polynomial functions, we got into sinusoidal functions. And so with sinusoidal functions, we were looking at the equation y equals a sine bx plus c and plus d. And so we had to look at what each of those parameters did. So a, for example, if we were talking about a Ferris wheel related to our radius, on the function, it was our amplitude. B was known as our period adjuster. So if you remember, our period adjuster was not the actual period, it just helped adjust the period. So period would be 2 pi over b. And b would be 2 pi over the period. Now, for C had to do with our phase shift or our horizontal shift. And in 30-2, we didn't have to worry about what that phase shift was, just whether there was one or not. So if C was anything other than 0, that meant the graph had been shifted left or right. And then for D, we had the vertical shift, okay? And this was also known as our midline. Now we had some formulas in here that we had to memorize. When we were looking at amplitude from a graph would have been our max minus our min divided by 2. And our displacement, or our midline, was like the average of the max and the min. So that would have been max plus min divided by 2. Now we also took and related this to a Ferris wheel. And what's neat about that is that the Ferris wheel can actually kind of fit right into our graph. So if I have my graph and then I want to draw my Ferris wheel, the amplitude here would also be the radius of the Ferris wheel. So the larger or smaller the radius, the larger or smaller the amplitude. And so amplitude is the distance from the max to the midline, or the midline to the minimum. So this would have been our amplitude. The period would be the time to do one revolution. So the time for the Ferris wheel to make one full rotation. And midline was one that sometimes we mixed up. Midline has to do with the distance from the center of the Ferris wheel to the ground. Okay, so midline is from that center point to the ground. And then from there, we looked at all different applications. If we were looking at period on a function, we were looking at how long it takes the graph to start a new pattern. Okay, so periodic functions means that the graph has a repeating pattern. And so the distance between those 2 points would be known as our period. Okay. And so let's take a look at some examples from your checkup or from your review. So I'm not going to go through all the examples, but I'm just going to kind of pull some out. Now, some key things we talked about, number of solutions. That's another way to talk about zeros or x-intercepts. If we're looking at the y-intercept, we're specifically looking at our constant. So for question number 2 here, if you're being asked for the y-intercept of -5, we're asking when the constant is equal to -5, and that would happen with D. All right, moving through here, we talk about quadrants. If you remember, our quadrants are quadrant 1, 2, 3, and 4. So if we're asking for a graph that extends from quadrant 2 to quadrant 4, that means it starts in 2, it ends in 4. They're in opposite directions, so we know it has to be an odd function or an odd degree. And if you notice, all of these have odd degrees. Okay, the fact that it's falling to the right tells us it's going to be a negative leading coefficient, so we can cross off A. And it says that we have to have a y-intercept of -6. So that means our constant has to be -6. And so we would cross out B, and then we would be left with C or D. Now it has 2 turning points. So at this point, I would probably venture a guess that it's D, but you could factor it, you could graph it to see if in fact that's the case. And so I believe D would be your final answer. Now, when we got into working with tables of values, we had to do different regressions. So we had quadratic regressions and cubic and so on. It's really important that when you're reading these questions, you read what kind of regression it is, so you're choosing the correct equation. Now, if for this question we're given a table of values and it talks about a hot water tank that sprung a leak, and then we're looking at the remaining volume over time. So we have time down here, and we have volume, and we're looking at what's happening to the water as it drains. And so we're asked to do a quadratic regression to estimate the volume remaining 20 minutes after the leak started. Well, 20 minutes refers to time, which is an x value, and if we know x and we're looking for y, we would trace. So in this case, we would trace at 40 minutes. Okay. And then we're asked to figure out when the tank is half full. Well, that's going to be our volume. If the original volume is 225, then we would look for half of that. So we'd look for half of 225, which is 112.5. And because that's a y value, we would draw a line at y equals 112.5, and we would intersect to find our x value, or in this case, t value for time. All right, so scrolling through, sometimes remember if we have an equation that's fairly easy to sub into, you don't necessarily have to trace or intersect. We can just take that value and sub it in. So here it asks, how long will it take for the volume to get to 0 liters? Well, 0 liters is a volume amount, so we can just plug in 0 equals negative 3.8 t plus 225, and we can rearrange to solve for t. So again, a lot of these questions are trace and intersect questions. You just have to ask yourself, do you know X or do you know Y, and what are you looking for? And then when we get into graphs, we were looking at midlines of the graphs. If you remember, that formula is max plus min divided by 2. So our maximum here is 4. Our minimum is negative 6. So it would be 4 plus negative 6 all divided by 2. So that would give me negative 2 divided by 2, which is negative 1. And so my equation of the midline wouldn't just be 1, it would be y equals 1. And so in this case here, it looks like there's a little bit of a typo. These should all say y equals. All right. And then when we're looking for amplitude, amplitude is going to be max minus min. So 4 minus a negative 6 divided by 2. 4 minus a negative 6 is 10. 10 divided by 2 is 5. Amplitudes will never be negative, so we can automatically cross off A. All right, so when we take out this equation here, it says a seat's position on a Ferris wheel can be modeled by the following function. And then we're asked first to determine the diameter of the Ferris wheel. Well, if you remember, A is for amplitude, which is also for radius. So if our radius equals 18, then we can use that to find our diameter. Which parameters of the equation change if the diameter of the Ferris wheel changes to 24 feet? Well, if we increase the radius, which means we're also increasing the diameter, then that means we're increasing our amplitude. Okay? It has no impact on our midline or our period, but it absolutely affects our amplitude. And then determine the time that elapses between the two minimum heights. Well, we would find our minimum heights, we would find the two minimums, and we would find the distance between them. So we'd actually have to figure out our x values for both spots and then subtract. All right, so moving on through this, we'll go on to rational expressions and equations. Now with this topic, this was a pink unit. This is one of the tougher topics. We looked at two different things. We looked at solving rational expressions and solving equations. Now the big difference is that an equation has an equal sign. So we started off by simplifying rational expressions, and in all cases, one of the most important things for this unit is to remember to factor first. Or as I have told you guys a few times, remember the F word. And it's not that F word that some of us might think of sometimes. All right. Now, with simplifying rational expressions, again, we have to factor first. We also have to remember to check for our NPVs, so non-permissible values. So a rational expression will always have some type of variable in the denominator, and since we can't divide by zero, that means we have to consider values that would make an expression non-permissible or not able to, or undefined. So for example, if I had 6 divided by x, x can't be 0 because that would make our expression undefined. Now I did say that x, there always has to be an x in the denominator. That's not totally true. X over 2 is also a rational expression. It's just that in this case, there would be no NPVs. So we wouldn't have to worry about NPVs for that one. So whenever we have an expression in the denominator, we just take and set it equal to 0 or not equal to 0. And we would solve from there. So if I have x squared minus 4, that means x plus 2 times x minus 2 can't equal 0. So x can't be plus or minus 2. Now, when we're simplifying expressions, we don't often see why we need to worry about NPVs, but when we get into solving equations, that's when we'll look for extraneous roots or things that aren't possible. Now, when we get into simplifying expressions, we looked at a couple different things. We looked at multiplying and dividing rational expressions. So if I had 6 over x times 3x over 4, we would multiply straight across. So 6 times 3 is 18. So I'd have 18x over 4x. And I would then be able to simplify. Now, at some point, I also have to remember to do my NPVs. In this case, x cannot be 0. Simplifying, my x's would cancel. 18 divided by 2 is 9. 4 divided by 2 is 2. And that leaves me with 9 over 2, such that x cannot be 0. Then we got into division. Okay, when we're looking at division, we have to consider extra pieces for our NPVs. So if I want to divide it by 3x over 4, the first step is to flip that second term. So I've got 6 over x times 4 over 3x, and that would give me 24 over 3x squared. 24 over 3 is 8, so I'd be left with 8 over x squared. And again, x cannot be 0. Now, when I'm doing my NPVs, though, I have to remember that I have to consider what I call the L. We have to consider all 3 positions because that second term is going to be flipped at some point. All right, after we left multiplying and dividing, then we got into adding and subtracting. Now with adding and subtracting, what we have to consider is our common denominator. So if I have 5 over 2x plus 3 over 2x, then I can just add them. 5 plus 2 is 8. 8 divided by 2x leaves us with 4 over x. Now, obviously, we got into some more difficult problems as we went that would have involved some factoring. So we'll take a look at some of those. Once we finished with expressions, then we got into solving equations. And with solving equations, we had 2 methods for solving. One was a special case, though, and that was cross-multiplying. And so with cross-multiplying, this only worked if I had a fraction set equal to a fraction. So if I had 6 over x equals to 5x over 2, then I could cross-multiply. I could multiply 6 times 2 is 12, and 5 times x is 5x squared. So I'd have 12 equals 5x squared, and then I could divide by 5 and square root to get my answer. The other way to solve was to multiply the entire equation by our common denominator, and in this case that would have been 2x. And as I multiply through, my x's cancel, so 6 times 2 is 12. Here my 2's cancel, and I'd be left with 5x squared. And again, we're at that same step, so then we would be able to solve. All right, so moving along here, we'll take a look at some examples. All right, so when we're looking at looking for NPVs, what we're doing is we're looking at the denominator and we're looking at what values would make this not equal to 0. So a plus 2 and a plus 3 can't equal 0. Therefore, a cannot be negative 2 and cannot be positive or cannot be negative 3. All right, let's take a look at this first example here. A student determines that the dimensions of the door to the conference hall can be written as a rational expression. Expressions for the length and the width of the door are shown. The area of the door to the concert hall can be expressed as a quadratic expression. And then we have this silly little puzzle we have to do at the end. But the first thing we're looking at is area of the door. That means we need to multiply this out. So 4x squared minus 1 times x minus 5 all times x squared minus 25 divided by 2x plus 1. The first step, and is always the first step, is to start by factoring. So when I break this down, 4x squared minus 1 is a difference of squares. So 2x plus 1, 2x minus 1, all divided by x minus 5, times x plus 5 times x minus 5, all divided by 2x plus 1. So sometimes by doing this, we'll find that things cancel quite quickly, and then everything gets simplified from there. So I have these all being canceled. My NPVs, x cannot be positive 5 and negative 1/2. We don't have to consider the numerator because we're multiplying, so nothing flips. And so my final answer there would be 2x minus 1 times x plus 5. When we look at our answers, we need it actually multiplied out to be ax squared plus bx plus c. So when we multiply that out, that gives me 2x squared plus 10x minus x minus 5. And so 2x squared plus 9x minus 5. And from there, it asks us to add up a, b, and c. So if I have 2x squared plus 9x minus 5, that means I'm taking 2, and I'm adding 9, and I'm subtracting 5. So 11 minus 5 would give me 6. All right, so again, hopefully you're seeing that factoring is always important. If we want to solve equations, so if I have 4x over 3x plus 4 minus 11 over x plus 6, there's two ways to solve this problem. One is to bring this over, and then we can cross multiply. The other is to multiply everything by 3x plus 4 and x plus 6. And when we're doing multiple choice questions, sometimes we're not asked for the final answer, we're asked for a step in the process. So sometimes it's not enough just to get to your answer or be able to plug in your answer. You have to be able to show that you recognize the steps in between. So if I was multiplying this through, first one, my 4x or 3x plus 4 would cancel, and I'd be left with 4x times x plus 6 minus 11 times 3x plus 4, and that would all be equal to 0. So when I draw my brackets, it needs to go around everything. All right, so I have 4x squared plus 24x minus 33x minus 44 equals 0. And then if we simplify, we have 4x squared, 24 minus 33 is negative 9x minus 44 equals 0. And then I can go about circling my answer. Now, if we're asked for the root of the rational equation, that's basically asking us to solve for x. Okay. And if we're asked for the positive root, whatever we get as our final answer, one will be positive, one will be negative. We put the positive answer into numerical response. Now in this unit, we also got into word problems. And so with word problems, we often looked at DST problems, distance, speed, and time. And there was 3 scenarios we could have. Either there was a total time, so we would take these two amounts and add them together. There was a difference in time, so sometimes we would subtract them. And then there was also where we would say that the times were equal, so we'd set them equal to each other. And so as we're going through this here, whatever the scenario is, we would fill in what we know, we would assign a variable, and then we'd solve for what we don't. Remember that t is always d over s, so distance over speed. We also looked at work problems. And remember with work problems, it was always 1 over an amount. So 1 over x plus maybe 1 over x minus 4 equals 1 over 15. So this would represent the fraction of the amount of work a person would do in 1 minute, the fraction of amount of work another person would do, and then the fraction together. So it'd probably be a good idea to go back and take a look at some of those word problems, as this was one that usually caused some trouble. All right, so again, when we're simplifying, remember you want to factor first. So for this one here, we would pull out a 12. We can pull out an x. That would leave us with x plus 2. On the denominator, we would have 6x squared. Our NPVs, x cannot be 0. And when we're simplifying, 12 divided by 6 is 2. X over x squared leaves an x on the bottom. And so we'd have 2 times x plus 2, all divided by x. Remember that we also had some special cases where if I had x minus 3 and 3 minus x, if I were to cancel those out, they would leave me with negative 1. All right, so if we want to simplify this, the first thing we should do is factor. So you've got 6x plus 5, 1 plus 2x, 1 minus 2x, minus 15 all over 2 times 1 plus 2x. Now we're looking for a common denominator, so this one is missing a 2, so we would put a 2 and a 2, and this one here is missing a 1 minus 2x. And so as I multiply this through, I would have 2 times 6, which is 12, so 12x plus 10, minus 15 plus 30x, and that's all over 2 times 1 plus 2x times 1 minus 2x. Now, if this was a multiple choice question, it's possible that the bottom would have been simplified to 2 bracket 1 minus 4x squared, or it could have been fully multiplied out, but I tend to leave it in factored form unless I have to switch it. And from there, we would go about simplifying. 12x plus 30x will give us a number, and 10 minus 15. And then again, don't forget to do NPVs, non-permissible values. All right, we've taken a look at multiplying and dividing. When we get into solving equations, remember again to factor first. So if I wanted to do part D here, I have m minus 3m, and then this becomes m times m minus 3. And so if I wanted to solve this, I would multiply the entire equation by m and m minus 3. And that would cause my m minus 3 to cancel, so I'd be left with 2m. The next one would cancel the m, so I'd be left with 1 times m minus 3. And then 6, and the m squared minus 3m cancels with the m times m minus 3. So from there, I could multiply this out and simplify. All right, so we got into some word problems. Here's an example. It says a retailer imports a crate of sunglasses for $4,500. 10 pairs of the sunglasses were defective and can't be sold. The retailer sells the remaining glasses for $8,900, and they get a profit of $5 per pair. Write and solve a rational equation to determine how many pairs of sunglasses he sold. So the question would be number of sunglasses. And in this case, we're going to say sunglasses purchased. So it's important that we know whether we're selling or buying. So we buy a crate of sunglasses for $4,500. So $4,500 divided by however many sunglasses I bought would give me the cost per sunglasses. But then 10 pairs were defective, and we sold the remaining pairs for $8,900. So that would be $8,900 divided by x minus 10, since 10 of the pairs were broken. And then it says they realize a profit of $5 per pair on the glasses he sold. Well, the amount of money that we made minus the amount of money that we spent should give us our overall profit, which is $5 per glasses. Now, if you remember, 4,500 over X is not the cost of all of the sunglasses, it's just the cost per sunglass, or per pair of sunglasses. And then so 5 would represent the profit per pair of sunglasses. And if we wanted to go about solving this, of course, I'd have to do my NPVs, but I'd also multiply my denominator by x and x minus 10. We took a look at DST problems already. We can also get into word or work problems. So Andrea and Lauren are responsible for shoveling their neighbor's driveway and sidewalk after a snowfall. After Andrea takes X minutes to complete the shoveling on his own, and Lauren takes 25 minutes longer. If they work together, it takes them half an hour to complete the shoveling. Well, Andrea takes X minutes to complete the shoveling, so 1 over X. And Lauren takes 25 minutes longer, so 1 over X plus 25. And their total amount worked together would be half an hour, which is 1 over 30. And then again, we can go about solving by getting rid of our denominator. All right, so that's where I'm going to leave this video for now. That's taken us through the first 2 units. Stay tuned, and I will send up or put together another video for tomorrow for the remaining units. All right, thanks guys. Have a great day, and we'll see you soon.